Today I'm going to be talking about ambiguity. What is ambiguity? Ambiguity is when a word can mean more than one thing. This is very common in almost every language. So until now, NLP++ hasn't had anything really specific for that, though each programmer using NLP++ and VisualText have been on their own. Amnon Myers, in fact, had dealt with this from the very beginning of his NLP career. And so it's really great that we're now introducing some new functionality, both in the NLP engine and some functions in the KB Funcs that you can use. And I'm going to tell you about them today. First of all, just a reminder of how to get to the tutorials. You come over here to the Analyzers tab and click on this little cog that says Load Example Analyzers. It will automatically open up the folder where these tutorials are. And in fact, you can come here and open up the NLP tutorials, and we're going to be doing tutorial number 15. And as you can see here, we have treating ambiguity. So with ambiguity, we have to store information about a word and its different meanings. And how do we do that? Because we have a dictionary, a .dict file. We also have a .kbb file. And of course, we have rules and functions that we can have. And obviously, you can do it in many ways. But in reality, the best way to do an ambiguity for a word is that's knowledge. The different uses of a word and all of the implications of those uses really are knowledge about the word. So for us to deal with ambiguity, we really have to deal with knowledge. So I'm going to start with the KBB first. And so here, what we have on our new mechanism for the NLP engine is we're going to be dealing with a dictionary and a KBB that are linked in a very specific way. Now, this has to be set up by hand to do this. So let's take a look. I have two files here. I have ambigs.dict and I have ambigs.kbb. Let's take a look at each one, both of these. Here is the dictionary file, and here is the KBB. So our dictionary file, we're going to use the word Google. In fact, if I look at the sentences we have, we know that Google is a verb and a noun. Did you Google his friend is a sentence, and he works at Google. So I'm going to show you how we can disambiguate these and get the right meaning of Google for this case using these new tools. So again, we're going to be looking at a dict file, a dictionary file, and a KB file. And you notice that the first thing that's super important for this to work is that they have to be the same name. So the way the NLP engine knows that these are working together, they have to be the same name. Now, why is this important? Well, because the dictionary function and the dictionary is different than the KB file. They're all in the conceptual grammar, in the brain of the computer, this hierarchical brain of NLP++, but they're done in very different ways. One is really for a quick lookup, and the other is for knowledge to be accessed. So we have our quick lookup here, which has our typical parts of speech, where we have Google is a verb and Google's a noun. We have them listed separately. Right now, we do those separately. So you can put different things with those verbs. Now, I'm going to put in here at and his, which is a preposition and a pronoun. And this is just for an example. This is not full NLP, full linguistic analysis. This is just to show you how it works. That's it. So this is extremely simplistic. All right. So then let's look at the KB. Remember, these are named the same names, ambigs and ambigs. So I come over here to the KB, and you notice that the very top of the first top concept is called dictionary. It has to be dictionary. The NLP engine, for it to match up a word that is looked up as in the dictionary and a word in its information here, you have to put it under what's called a dictionary. Second, under the dictionary, the concept under the dictionary, all the children are going to be the names or words that are in the dictionary. They have to be the same. So you have Google. And then we have a specific representation here. I have meaning 1, MO1, MO2, and these will be all the meanings. And you notice it's more than syntax now. I have a verb, and I'm saying it's a synonymous with search. Here, and when it's a noun, it's a company, an entity. So that is when we look at this sentence here, these two sentences, we should get in the tree the information that this will be a verb. It won't, even though it's a verb and a noun, that will eventually, when we're done with our analyzer over here and our disambiguation, we should hit that this is a verb, and that's the type search, and we should get this as Google as a noun, and it's an entity, and it's a company. So that's what we want to end up doing. So again, repeating, these two are the same, ambigs.dict and ambigs.kbb. You have Google in the, sorry about that. You have Google in the dictionary, and the parts of speech have to be listed separately, each line. And then I have a couple other things that are just going to be helpers that I'm going to use. And then over here, you have a specific dictionary word with the words under here. If I were to have more words and more meanings, I would put them there. And the information of part of speech, and also any other information. Now, this can be anything. This part of speech is here, but and we're going to be using it because almost every part of ambiguity is going to deal with the part of speech. That's one of the ways we can find which verb, which word, which part of speech a word is in a particular context. Okay, so now let's take a look at the text again and our analyzer. So we have a dictionary to tokenizer that removes spaces. Now, remembering that you have to use a dictionary. If you right click here, there's a dictionary and a dictionary. These two, you're going to have to use one of these because those are the way the analyzer knows I need to look and load up the dictionary. If you just do a tokenize, it's not going to load anything up here. Now we have also the KB functions. Again, how do you get KB functions? You go here to library paths. That's the first thing. These are really, really useful. I think almost everybody has this loaded into an analyzer. Maybe eventually it will be even just defaulted in because so many people use it. Again, you go to library paths, click on that. Now we've added some new functionality here recently. Some for JSON and some for, let me just give this some more room now. Let me, and we now have some for ambiguity. So if we go down a little further, there's the JSON ones that are newer, again, when we recorded this, and here's the ambiguity. So we have one called ambiguity trim part of speech, and we have ambiguity copy adders, and then we also have, is this part of speech, is this a part of speech? Because I'll talk to you a little bit about that. So these functions, we're going to be just using this function uses these others. And we got some very interesting things going on. And lastly, we're going to have our rules to do disambiguation. So these ambiguous words we're going to look at. So here's one, he works at Google, and then for a rule for that, and did you Google his friend? And so what are we going to do? We're going to look at two words. Let me split the screen and put the sentences here. We're going to look at two words. So we're going to say, we're going to match any alphanumeric. So it's going to look at one alphanumeric followed by another. And it's going to have a precondition. It's going to say that the first word I'm looking at must be a preposition. And then the second word must be, at least it's going to be a noun. And that second word is ambiguous. How do we know that? Well, we use this the variable is greater than 1. That is the part of speech count. The number of parts of speech is going to be greater than 1. So we're not going to fire this or do a disambiguation unless the part of speech there's more than 1. Here's the second rule that says, oh, if the first alphanumeric, oops, this is wrong. All right, and so the first one is looking at the alphanumeric. So let's take a look at the second rule. The second rule has another alphanumeric followed by an alphanumeric with different conditions. The first one is that the first one now is a verb, okay? And the second word is a pronoun. So this is Google his, okay? And if you say you're going to Google his something, then the object of Google is something, then that is going to be considered a verb. Yes, linguistically, this is not perfect. The idea is that this is not to be perfect. It's to show you how this works in a pretty simplest way. And there's some merit to these rules. So, okay, so that's what's going to happen. We're going to match it. He works at Google, so it's going to look at this first one, and it's going to find that at is going to match, and then Google is going to match the second one. And then if it matches these it's going to, you'll see when we run it, it'll match. It's going to call this function ambig trim part of speech. What does this do? It takes the second node, you hand it to second node, and you say, I want you to choose the part of speech noun and everything that comes with it, and get rid of everything else. I'm going to say it again. I want you to look into the knowledge base. I want you to look into the knowledge base, find the meaning that has noun, the part of speech noun, bring all those attributes over in the tree. This is going from the KBB to the tree, and I want you to get rid of all the other ones. If it's a verb, get rid of the verb information. So that's what this does. So let's go ahead and run this and see what goes on, all right? We're running it. Now let's take a look at the matching here, okay? Well, let's take a look, I'm sorry, at the tokenization. Now, if you click on the tokenization, you can see what we've looked up. In fact, you can do this. We'll click on this, and you're going to see that the tokenization, when you look at it, has matched these things. And this comes from the dictionary. In fact, if you say view rule or dictionary match, it will do that, and it'll show you, oh, it came from the dictionary. Okay, so that is a nice feature that we've just added recently too. So you can, on the dictionary, on the tokenizer, you can look at what it's matched, and you can then right click on this and see where in the dictionary it's looked it up. Let's take a look at the tree, and let's close this all out. And in the tree, you're going to see here that Google here, if you look at it, it's wrapping, okay, that there's part of speech, there's two. It's marked as a verb, it's marked as a noun, and this is the thing. This is where the engine is helping us out. It has said, oh, I noticed that these two have the same name. I also looked into my KBB. Do you have a dictionary? And I'm going to go see if I match the word. When the dictionary matcher in the tokenizer says, I found Google, let me go. Is there a KBB with the same name? Oh, there is. Is there a dictionary under that? Nope, there is. And if there is, it's going to look at Google, and it's going to put that in the tree and point to it. So what this is doing here is let's click on this again and click on this. And what it does then, it says that I found Google, but you notice that this has never happened before. It's coming back with, in the tree, a pointer to the concept. Now, this is just the leaf node of the concept. This is under the dictionary. For display means just for display, because this is what this is. It's not showing you where the whole tree. In the future, we may want to do that, but it's okay. So it's saying that, oh, I found the word Google. So it's pointing to, where is it pointing to? It's pointing to this. It's not pointing to with a meaning. It's saying, I found you. There are several meanings there, and here's those meanings. So we can use that one further on in our parsing with that one function we're looking at. So again, we've got to click on here, and we got to click on here. All right. And so you see that there's concept, verb, noun, two parts of speech, so it's ambiguous. Here you see Google again, same thing, meaning, pointing to the meaning, verb, noun, two parts of speech. It's ambiguous right now. So let's take a look at the ambiguous pass. Let's click on here, and we're going to see which rules have matched. We've seen that there's one rule here that matched Google and his. That's a ambiguous word and a pronoun, and we have one here with the preposition and Google. So those two have matched. Let's take a look at the tree and see what we have now. Okay. Now, if we look at the tree, we're going to look at, here's Google, his friend. It's fired, and now you notice that here there's only one part of speech. You notice it's a verb. And you notice now, instead of pointing to the Google, it's pointing to M01 under Google. Again, this doesn't show you the whole tree. That's something, again, I should probably put in there to make it easier to read. But this is, so you can see that our rules worked just out of the box. And here we have at Google, and that's, again, you see it fired there. Here you see Google, his. How do you know it's fired? Just look for the word fired. And then here you also have fired. And you said at Google, and you notice here it's different. Now it's a noun, and its part of speech is one. It's an entity company. Up here you see it's a synonym for search. Again, these are not the way you would necessarily label these. These are the way I'm labeling it for this particular way, a demonstration for this tutorial. So yes, we have now disambiguated. No longer is this a noun and a verb, it's a verb. And not only that, we know which meaning of it. You can have all kinds of rich information. It's going to bring it here and put it onto into the tree. Now you have a word with more rich information. You know what meaning it is, and that's the idea. Now, I'm going to now go into the function that does this. So if you're not super interested in that, you can stop now, but I'm going to look at the function and how this actually works. So let's take a look at this function, ambiguous part of speech trim. Okay, we're going to go to that function, and we're going to see that here, what's going to happen is it says, okay, here's the node in the tree. Let's take a look at the tree over here. And let's look at the tree just before that. So I'm going to list this tree here. Again, it's kind of all, let's see, think I can get rid of that. There we go. So let's take a look here. So what we have here is we are looking at Google, and it's got a part of speech 2, and it has a meaning. So here we're passing the node, which is, remember, a node is the tree. A concept is the brain. The tree is the text that's come in. That's the way NLP++ is. Cognitive model. We say that the text comes in and people chunk those and they organize that in a syntactic way. But then on top of that, then there's meaning. We don't do full trees. That's our parser does that, but we're more interested in the phrase. We think people deal with things that way more. So anyways, the ambig trim pos function, which comes with, you hand it the node, the tree node. So we're handing it Google, and in there it has the meaning concept. And that's the first thing it does. It says, go look at the node variable on this node called meaning. If there is none, we can't disambiguate it. We can't do anything. We'll go on. If there is, we're going to go and we're going to look at below. We're going to look at, I've got to come back here. We're going to look at then the KB for the dictionary and for Google. So we're going to go down and we're going to get it from the meaning, and now we have this concept, okay? Each meaning. I should probably change this to meaning instead of concept, but I have it as concept to make it a little clearer. So we're now looping through M1 and M2. We're going down from meaning. The meaning, we're getting the pointer to the meaning, which points to Google. That's what's in meaning now. It's pointing to the Google concept. We're going down from it to the children and looping through it. So we're going through, and now we're going to look at the part of speech. We're going to get the value of the attribute of this concept called part of speech. And that's going to get us verb the first time and noun. We are passing it from the rule, the part of speech. If we go back to the actual rule here we go. We're going to see that we're passing it the part of speech. We're either passing it a noun, just hard-coded in, because why? Well, if you have a preposition followed by a noun with Google, we're going to go and say it's going to be a noun, because a prep in front of a noun is going to be a prep in front of something that can be a noun or a verb is going to be a noun. Again, this is a simplistic rule. It works. But and then so that we pass it down here, we're going to say, oh, if you have a verb, a possible verb that's ambiguous, but it can be a verb followed by a pronoun. Well, that one we're going to call a verb. So that's what this function does. It says, you guys will set up the situation, the rules for whatever rule. Again, that's why NLP++ is so fantastic. You can build this to whatever you want, and so that's what you're going to want to do, is build this up. And make it the way you want in your rules. But when you finally got the conditions, you're going to say, okay, I'm going to now disambiguate it and treat this ambiguity. I'm going to call it a noun, and you get rid of everything that I got from my KB and put it in. So that's what's being passed here. So let me close this out, and let's continue here. We'll just leave it like this. So we're going through. We're getting the part of speech, and let's go back to the KB. So we're back here with our ambig trim pos function, and we're getting the part of speech. There it is. And then we're saying, is that part of speech what we're handing? So let's say we're handing it the noun. All right, we want it to be a noun. We want you to go find the noun meaning, and that's what we're going to fix up. We're going to get rid of everything in the tree. So this, the big thing about this function is it's going to take in a node, and a part of speech. It's going to go into the KBB and it's going to find the right meaning and then put those on the tree. So we're going through here and we're going through first meaning one. So con is at MO1. It looks at the first part of speech where we've handed it a noun. It says verb, nope, not equal. Go to the next one. Goes now we're in MO2. And it says, does that match noun? Yes, it does. Once it matches, what we do is we copy, we call the function to copy the attributes from the node, from the concept in here, these things, and to the node. We copy that. We don't, and if you look down here, you'll notice that we don't copy the part of speech. So whatever we had, we may have a bunch of stuff here. We could have lots and lots of characterizations of the meaning for the verb Google here. Whatever you want to put in there. Well, this will copy them all except for part of speech. Then what we're going to do is we're going to replace the value of the parts of speech. We know that in the tree, the part of the POS number for Google is going to have 2. So we want to set it to 1 because it's now only 1. There could be much more than 1. And then we're also going to replace the meaning with the concept that we have now. Right now, in the tree, we're pointing to Google. We now want to point to the meaning, the MO1, so that in the tree we know, oh no, it's this particular meaning of Google. So that's what this does. And these are functions for the node. We're doing tree functions. That's what this is. These are tree functions. Starts with PN. That's how we know. Whereas you can see these cons, they don't. A PN next goes to the next node in a tree. The next here, just a plain old next, goes to the next concept in a KB. So those are the two types of functions we have. The last part of this function is going to say, I need to now get rid of everything. So I go and I go and look at getting all the names of the variables on the parse tree. So let's take a look at the parse tree here. So we're going to get everything that's in this tree. So for instance, with Google down here, we're looking at the noun, and it's going to go through and it's going to see SP, that's spaces. Lowercase is 1, it's lowercase. Meaning, it'll be MO2 in this case. Verb, noun, part of speech. So this is what this does. This gets all the attribute names in a tree and returns them, all these names. So this is the name. This is SP, lower, meaning, verb, noun, POSM, no. So it's going to go through that. And what we are doing is this is an array. So an array in NLP++, you put these square brackets, and I'm using I as the counter, and we don't have to initialize anything if once it gets automatically initialized. So what this is saying, I'm at I and 0, and I'm going to get that name here. That's all this is. And it says, is this a part of speech? Now I have down here, I have, is it a part of speech? And here are all the different parts of speech. Again, for every language, whatever you're doing, could be a wholly different it just depends on, again, it's a glass box. You can do what you want. So that's what it's going to do. And it's going to go through, and if it finds anything that's a part of speech that's not the part of speech that we had handed in, I'm sorry, I said that wrong. The part of speech that comes in like noun, it's saying that, oh, is it a part of speech? And does the name of that not equal the part of speech that we passed in? So if it's a noun, for instance, if it's not going to remove noun because it says, no, it can't, if the attribute is a noun, don't remove it. But if it's something else, anything else, and it's a part of speech, remove it. So this means if you have anything else on there, it's going to stay. The only thing that's going to be removed are parts of speech. So that's what that does. So going back to this entire thing and summing up, what we have now is several mechanisms in order to deal with ambiguity. First, we have to remember ambiguity and the information about ambiguity needs to be stored in a knowledge base. That's where it needs to be stored, not in a tree. Why would you put it in a tree, all the possible meanings? That doesn't make sense. And for us to make that connection, you've got to have a dictionary and a KB with the same names, the same first part of the file name, and you have to have in the ambigs a dictionary, a top level concept called dictionary, and underneath it all the words, and meanings under here. Now, that's what you have. And you can really call this anything you want. I just put MO1, MO2. It doesn't matter because it just goes through it. It's going to look for meanings. So it knows that you have to have a dictionary. Under that, you have words, and under that are all the meanings. It's just in that order. The word dictionary has to be dictionary, and these words have to match the words that are in here if you want this to work. Secondly, we have functions, this ambiguity function called ambiguity trim part of speech, which again, what's good about this is you can change it. It's a glass box. This is the difference between NLP++ and core NLP, for example. Core NLP has siloed things, and if you need to change something, it's not so easy to change. You got to kind of use their packages. This is 100% box, glass box. And finally, you then can make these functions with preconditions to disambiguate using syntax, and then call the ambiguity trim, and you end up with a final tree, in this case here, final tree, in which you have now that this Google is a verb, and it's a synonymous for search, and this Google is a noun, and it's an entity. So I hope you've enjoyed these new tools for ambiguity. Go at it. If you ever have any questions, you can always contact us. But these are really great mechanisms in doing this in a very principled way, that ambiguity and word meaning is stored in our brains. And when we see text, we have to decide which one of those things are there. And this will allow us to do that.